Hello all, welcome to yet another live session of Narayana IAS Academy. So as you can see, today's session is all about discussing the geography questions that have actually appeared in your examination, that is GS1 paper. So let us actually get started. We'll be actually discussing what are the approaches to these particular questions, and also we'll be understanding certain concepts, okay, which are relevant for the examination. Now let's move forward. So question number 3 that has been asked in your examination is about what is the sea surface temperature and what is sea surface temperature rise and how does it affect the formation of tropical cyclones. Okay, so you must know that of late there have been lot of incidences or instances of tropical cyclones, and that is actually a result of an increased sea surface temperature. That's why this particular article, this particular topic or the question has actually come in your paper. Okay, so as we discussed in our previous discussion, every answer must actually have 5 parts, that is introduction, the body, the conclusion, the flow, as well as the presentation, right? So over here in the introduction, I would like to say that here in the introduction itself, you must not start with what is sea surface temperature, okay? Because this is the main question that has been asked. So sea surface temperature and the impact of sea surface temperature on the tropical cyclones should be dealt in the body part. So in the introduction, what shall be written is that you can say the increase in the sea surface temperature has been a crucial indicator of climate change. Okay, and of late, if you see over the past 4 decades, there has been an average increase of sea surface temperature of over 0.6 degrees Celsius. So this can actually be your introduction. Okay, now moving on to the body, we'll be discussing about what is sea surface temperature. You know, right? What is sea surface temperature? Sea surface temperature is nothing but, 1 minute. Yeah, so let us actually see this one also, because I've directly mapped to the syllabus, because important geophysical phenomena such as earthquake, tsunami, volcanic activity, cyclone, etc. are important. Okay, so over here, your landslides, the cloud burst, then you have the tornadoes, you have the tropical cyclone. So all these also form a part of it. Okay, so as I told you, an answer shall actually have an introduction, body, conclusion, flow, presentation. Okay, the introduction also, we said that there can be a definitional approach, there can actually be some facts, there can be relevance, there can be an historical incident that was actually that was in news with respect to a particular topic. The relevance and the historical underpinning, that can be with respect to history answers. So since it's actually geography, let's see how we'll have to deal with this particular answer. So that's what I told you, a definitional approach, the current affairs, the fact or data, relevance, or the historical reference. So over here, these two can be done with respect to that of your history. Okay. So what can be the possible introduction? So this particular topic is actually from the geophysical phenomena, and here we have to understand this particular concept of sea surface temperature. Okay. Now before moving into the tropical cyclones, here let me actually tell you the concept of tropical cyclones, how sea surface temperature affects the tropical cyclones, that is the formation of tropical cyclones, so that you will know how to form your answer. Okay, so here in the introduction, I told you, let it actually not be a very a very lengthy definition about sea surface temperature. Instead, we can actually say that sea surface temperature has been a crucial indicator. So what did we say? It has been a crucial indicator of climate change. Of late and over the past 4 decades, there has been an average increase of over 0.6 degrees Celsius over the past 4 decades. Okay, so this is what you will actually see. Now coming to the body, we will discuss about what is sea surface temperature. What is sea surface temperature? This is nothing but, break it, sea surface temperature. So what is sea surface temperature? It is increase in the temperature of the uppermost layer of water or ocean. Okay, of ocean water. So this is what is called as sea surface temperature. Okay, what are the causes of increase in the temperature of the uppermost layer? That is, one is because of causes of sea surface temperature include global warming. What is global warming? It is because of the anthropogenic activities. When there is excessive release of the greenhouse gases into the atmosphere traps it, increases the heat, and the oceans actually behave as the sinks or absorption medium of carbon dioxide and other greenhouse gases. That is why the ocean warms up, and hence the sea surface temperature increases. Okay, so this is the body. So this is the definition of sea surface temperature. Now we have actually dealt with what is the sea surface temperature rise. Okay, so first part of your body is over. Now we need to deal with how does it affect the formation of tropical cyclones. Okay, so now let us quickly understand this particular concept of tropical cyclones. So what do you mean by tropical cyclones? For example, let me deal with the concept for a couple of minutes. So first of all, this is the surface of your earth, and this actually happens to be your equator. Okay, so this is your equator, and this is your Tropic of Cancer, that is 23.5 degree north, and this is Tropic of Capricorn, that is 23.5 degree south. Okay, so how is the movement of winds? So here there is a low pressure system. What do you mean by low pressure system? Whichever area is characterized by an increased surface temperature, okay, where the temperature is more. So in the low pressure system, what happens? The wind or the air system actually rises. Okay, so over here I will indicate, imagine that, okay, so let me do it again. This is the surface of the earth. Here you have the equator. Here you have the Tropic of Cancer, 23.5 north, and here you have 23.5 south. Okay, Tropic of Cancer and Tropic of Capricorn. If there is a low pressure, if this is a low pressure region, what happens is that the air from here actually rises. Okay, imagine from outside the board, air from here rises because it's a low pressure, and air always moves from low pressure to high pressure. Do you understand? So the air actually rises and it actually moves towards the high pressure region. So this is a high pressure region. So when the air moves, so this is all happening in the upper atmosphere. Okay, so when it moves to the high pressure region, what happens is that there the air actually cools down and it sinks. So when it sinks on the surface, it is actually like this. So it comes from high pressure to the low pressure region, right? But the movement of the air or the direction of the wind is not the same, because it is actually under the influence or the impact of something called as the Coriolis force. So what is this Coriolis force? This is a force which actually causes the deflection of the winds. Okay, and this deflection is actually towards the right side in the northern hemisphere, and it is towards the left side in the southern hemisphere. Okay, so here if you see, this is actually the direction of the wind from high pressure to low pressure, and because of this particular Coriolis force, there is deflection of this particular wind towards the right. Okay, so right as in it is actually like this. So in this zone, the movement of the air is actually like the movement of the wind system is like this. Okay, since it is in the northeastern direction, these winds are called as the northeast trades. And similarly, in the southern hemisphere, what happens is that the air actually rises from the low pressure and then moves towards the high pressure. And then what happens? From high pressure, it actually sinks, it descends and moves towards the low pressure. And because of the Coriolis force, it actually deflects towards the left side in the southern hemisphere. So here, the wind system moves like this. Okay. So this is actually called as the southeast trades. So this is what generally happens. So this is the general phenomena that actually takes place in the wind system. Now, how are tropical cyclones formed? As the name suggests, that it is formed in the tropical regions where the surface temperature is already high. So for example, this is the equator. This is your Tropic of Cancer. And this is your Tropic of Capricorn. Since we are talking about the tropics, I'm actually telling you. So for example, if this is the low pressure system, that is the water or the sea surface temperature of the ocean over here as actually increase. So it results in the formation of low pressure. Now what happens is that the air from here or the winds actually move over here, and when it actually is moving towards the high pressure, what happens is that the surrounding air from the high pressure region. So when this is low pressure, surrounding region is surrounded by what? High pressure. So winds from here actually gush from all the sides, and this direction is called anti-clockwise direction, and that is characterized by swirling of the winds. Okay, so swirling of the winds around a low pressure center is called as a tropical cyclone. So this is what it happens. Okay, so use this only over here, because when there is a low pressure system, what happens? The wind actually moves like this. Then what happens? Wind from high pressure regions gushes over here, then again it moves like this. So eventually it actually moves in the anti-clockwise direction, and that is actually the characteristic of a tropical cyclone. So this is what tropical cyclones are formed, and the tropical cyclones, the driving factors actually include four. That is, it must actually have a sea surface temperature. Yeah, so it must have a sea surface temperature of around 26 to 27 degrees Celsius. Also, it must actually have low wind shear. Okay, so what do you mean by low wind shear? That is, what to say, the speed of the wind actually varies with respect to that of altitude. Okay, so if this is the wind that raises up from the surface, what happens? The speed here is different and the direction also can be different. Here the speed is different and the direction can be different. However, the difference in the speed and the direction and the nature of the wind, that is, even the temperature of the wind, is actually very important. And if it is actually less, it is called as a low wind shear. When if it is more, it is called as the high wind shear. And for a tropical cyclone to be formed, it has to have a low wind shear, and also it must have a pre-existing low pressure. Pre-existing low pressure should be there, and also it must have the Coriolis force. So we saw how Coriolis force was responsible for the formation of the tropical cyclones. Okay, so now you've understood what is a tropical cyclone. We've seen what is the sea surface temperature, and now how does that affect the formation of tropical cyclones is the important part. So how does it affect the formation of tropical cyclones? Is there are few points. The first point, how does it affect, is that increased evaporation. So first one is what? How does it increase it? So first one is increased evaporation. So when there is an increased sea surface temperature, what happens? There is actually evaporation from the surface of the water, right? So here it adds, okay, so when there is increased evaporation, it adds moisture to the surface and the atmosphere. Okay, so here this is an example where cyclone Amphan of 2020 was actually characterized, or it was a resultant, and the tropical cyclones actually formed because of increased evaporation. Next one is release of latent heat. So what do you mean by release of latent heat? Latent heat is nothing but, according to thermodynamics, actually water or moisture exists in three forms. That is, the solid form, this is nothing but ice, and then it undergoes evaporation and becomes liquid, and this is nothing but water, and this undergoes evaporation and it actually becomes vapor or moisture. This is nothing but the gaseous state. Now what happens when there is actually more and more evaporation of water? Then water actually becomes moisture, and moisture gets into the upper atmosphere. Then it actually condenses to form clouds. There condensation actually is taking place. Condensation is what? It is the conversion of this moisture into water. Then only you will have rain or precipitation, right? So during This, so whatever, whenever a matter, in this case it is water, when that is actually changing from one state to another, there is a release of latent heat. When there is latent heat release, what happens? It further increases the temperature, and that actually lays the foundation for the formation of tropical cyclone. So this is also one of the example. Next one is, there is lower atmospheric pressure, that we already know. Here the example was, this was cyclone Amphan, this was cyclone Fani, and here is actually lower atmospheric pressure. Okay, so this is what we know, that there has to be a pre-existing, low pressure. That is when the surrounding, air from the high pressure region gushes, it actually twists the system, moves in the anti-clockwise direction. And this example is cyclone Tokte. So this was in the year 2021. Next one, I told you there is a change of wind shear. So when wind shear reduction is actually there. Wind shear reduction. And the final one is longer duration. Sometimes, because the system actually gets warmer and warmer, what happens is that the tropical cyclones become very, very intense, and it can even move from this tropics to the upper the subtropics. Okay, so that is what is actually called over here. So this is actually the discussion about the tropical cyclones and what are the reasons that actually what is the cause or the impact of sea surface temperature on the tropical cyclones. So finally, how we will actually end the answer is, increasing sea surface temperature is a great concern for India. Okay, specifically we are actually surrounded by the Indian Ocean, Bay of Bengal, as well as the Arabian Sea. So we actually need to follow, or take up, in order to achieve the SDG 13, that is climate action, we need to actually take up the essential steps that have been mentioned there. Okay, so this is what is your discussion on this particular question. Now moving forward, this is actually the the diagram that I wanted to show with respect to that of cyclones. If you actually can see, the sea surface temperature is 26 degrees. Here what happens, there is evaporation of the sea surface temperature, the evaporation of the water, then it actually moves as moisture, then undergoes condensation, and then what happens, there is actually swirl over here, and then it pours down as rain. So this is the this is the diagram of tropical cyclones, and this is called as the eye of the cyclone. Okay, now moving forward, the next question, what is the phenomenon of cloudburst? Explain. So here we'll again understand what is cloudburst. So cloudburst over here you can actually introduce, because this entire Yeah. So cloudburst, here you can actually introduce, because the question is very simple. What is the phenomenon of cloudburst? Explain. Okay. So in the beginning itself, you can actually give an introduction stating that the cloudburst is an intense and a sudden downpour of rainfall. Okay. So this is what it is. And so here you start by giving the definition. You will say it is intense downpour of rainfall, typically which is actually localized to a very, very small area, and you say more than 10, that is 100 millimeter of rain can fall within can actually fall within a period of 1 hour. Okay, so this actually causes intense rainfall over a particular area. So why do that this particular cloudburst actually occur? So what is actually the phenomena of condensation? How does precipitation actually happen after condensation? Let's understand that. Okay, so first imagine that imagine that you are over here. Okay, this is the surface, this is not atmosphere, this is the earth's surface, you are over here. What happens is, you need to understand one thing: air holds moisture. Similarly, if you see, warm air will hold more moisture. Okay, So when the surface is actually warm, what happens is that there will be, so this will be characterized by low pressure, and now what happens is that the winds actually tend to rise. And now the air, warm air will rise. So here warm air with more moisture will rise. For example, if this is 30°C, okay, if the temperature of this place is there, and here the air actually constitutes, let's say, around 100 molecules of water. Okay, now as the air rises and as it actually reaches the upper atmosphere, the temperature of course decreases. So what happens is that at 20 degrees, the air that actually contained 100 molecules of water will actually contain only 60 molecules of water. So what happens to the remaining molecules? This actually gets dissipated out as the condensation nuclei. Okay, so this is the condensation nuclei. So these condensation nuclei will actually have or attract the water molecules, and then there will be formation of clouds. And again the surface will get more heated, then there is again rising of the air, the clouds actually gets built up, and at one point what happens is that the clouds will reach the saturation point and hence cannot hold any more moisture, and that is why we have a sudden downpour of rainfall that is called as regular precipitation. Why is cloudburst actually happening is that this is typically in areas which is actually characterized by steep slopes or mountainous regions. So what happens? The same process, imagine when this is a mountain. So when the same process actually takes place in the mountain, the wind actually has to climb the slope of the mountain. Okay. So here itself you have the formation of the clouds. So what happens? The clouds have to reach a higher height where the temperature difference is actually a lot. So by the time the clouds reach over here, they lose their, their bearing capacity of moisture, and hence what happens, there is a sudden downpour of moisture or rainfall that is called as the cloud burst over a particular area. Okay, so this is what it is. So mechanism of cloud burst I have actually explained, and this is particularly characterized by steep topography we actually discussed. So what are the factors contributing? As I told you, first one is orographic lift. What is orographic lift? Orographic lift is nothing but the presence of a steep topography like a mountain, etc., such as the lake cloudburst that actually happened few years back. So first one is orographic lift. The second one is temperature difference. I told you what is the temperature difference. The next one, it is characterized by localized thunderstorms. So what do you mean by thunderstorms? Thunderstorms are nothing but, in simple terms, I'll actually tell you. For example, what is a convection cell? Convection cell is nothing but the, warm air from a low pressure area actually, rises. Then what happens is that it reaches high pressure, then it actually sinks from there. Okay, so this is called as the convection cell. So when this convection cell takes place over a large area, okay, so when this convection cell takes place over a large area, that is characterized by increased temperature and increase in the low pressure, then what happens, that actually results in the occurrence of thunderstorms. Okay, so that results in thunderstorms, and here thunderstorms are characterized by huge vertical clouds. Okay, so they have huge vertical clouds, and these clouds have charged particles. Okay, and when these charged particles actually collide with each other, what happens is that they discharge electricity, and that is why you hear that sound that is called as thunder. That is, thunder is just the effect or the outcome of this thunderstorm, and also it is characterized by lightning. So now I hope you understood what is the localized thunderstorms. So we have discussed about the phenomena of cloudburst. They've asked to explain. Here it happens because of the orographic lift, the difference in the temperature. And next one, it's characterized by the localized thunderstorms. Okay. Now what can be the effects of cloudburst? They are very, very simple. First is it results in flash floods. Next, it actually results in landslides, as you know, and also it actually results in a lot of casualties and damage. And for each of this, you can actually cite examples. Okay, for example, a lot of incidences have been happening in Uttarakhand, then Himachal Pradesh. So all these regions can be cited as examples. Okay, so again, here you can connect it with SDG 11, that is sustainable cities, how the planning has to be and what are the precautionary and mitigation measures that you need to take. Now moving forward, next one is actually a very what to say, simple question that we'll be dealing with. I am not able to move this slide. Yeah, so we just had a glitch in between. So over here, this is actually the explanation. Again, cloudburst forms a part of important geophysical phenomena like earthquake, tsunami, etc. And this is actually your diagram. There you can see the moist air that is actually rising. Then it actually has condensation. Here there is lot of precipitation. This is the rain shadow region, because by the time it actually ascends, what happens is that the clouds actually lose their bearing capacity of moisture and hence the rainfall. Okay, so this is what is, yeah, this is what is all about the phenomena of cloudbursts. Okay, now we'll move on to the next one. The groundwater potential of the Gangetic Valley is on a serious decline, and how it may affect the food security of India. It's a very, very, what to say, it's a very generalistic, question, because recently we had the groundwater report that was actually released. So based on that, it is important for all of us to note down what are the characteristic features or the situation or condition of groundwater in different parts of the country. Okay, so here in the introduction, you can actually talk about the recent. So over here, you can talk about the recent report by the Central Groundwater Authority. So here the Central Groundwater Authority had actually said that the storage levels in the Ganga have been decreasing by around 2.6 centimeters per year. And also now towards the body. So here you have actually given a fact that we already discussed about. And now moving on to the body, you can actually talk about what are the factors that actually leads to the groundwater depletion. The first one can be, over extraction of water, over extraction of water for agriculture. So this is understood. because for the purpose of agriculture, almost Uttar Pradesh and in Bihar, 90% of irrigation for agriculture is actually based on groundwater. So that can be your first point. The second point can be industrial and for domestic use. We use water for industrial and domestic use. For example, we have different industries that are actually located in cities like Kanpur. So here this can be one other reason. Next one is climate change impact can be there. What is climate change impact? It is because of the erratic rainfall. Then it can be because of the what to say, the vagaries of nature. There are different drought conditions, etc. So that can also be one of the reason. Next one, there is always inefficient water management. Okay, so efficiency in the usage of water for your irrigation purposes is actually not done. Okay, for example, instead of adopting to drip irrigation, many people still actually use traditional flood irrigation, that is by using those hose pipes, which leads to excessive use of water. Okay, so this is it. So the groundwater potential of Gangetic Valley is on a serious decline. You've addressed it because you've actually stated some facts that has been given by the given by the organization. What was the organization? It was the Central Groundwater Authority. Yes. So you had given on that, and then you actually, yeah, see, you were Central Groundwater Authority, and you actually talk about different factors. It is because of over extraction for agriculture, industrial and domestic purposes, climate change, as well as inefficient water management. How can this actually impact the India's food security? This is something very, very it is very basic. If you think that how does declining groundwater actually impact India's food security? Because number one, if there is inefficient or improper water usage, then there is going to be what? Reduced agricultural output, right? Reduced agricultural output. The next is going to be increased cost of farming, because they have to dig deeper wells to actually extract water for your crops. The next one can be, there has to be shift to water intensive crops. So this can be an impact on India's food security. The next one can be, there can be impact on livelihoods, especially in the rural areas, and also there will be compromised food security goals. So these can be the outcomes or the impact on India's food security because of inefficient or over extraction of groundwater. So this can be the answer for this. Now moving forward. So this can actually be mapped to geographical features and their location changes in critical geographical features. That is, how is the water bodies getting depleted in these areas. So this particular portion discusses about that. Next one is a simple question. I will directly explain what it is. What are Aurora Australis and Borealis, and how are these triggered? Because recently you have been, so much have been in news because of, the auroras that have been seen in Ladakh. Some were actually seen in Canada. Okay, so that is why this question was in news. So generally what happens is, this is the surface of the sun. Surface of the sun. Okay, so the visible portion of the sun is actually called as the photosphere, and the layer that is the outermost of this visible portion of photosphere is actually called as the corona. So what happens is, there are rays that actually comes from the sun towards the earth. Okay, so these are called as coronal mass ejections, or they are also called as solar flares. Okay, so these solar flares are highly charged. Okay, and when these charged particles actually move towards the earth, when they move, what happens is that they create magnetic field. Okay, so when they move towards the earth, what happens is that if you imagine Earth as a magnet, this as the north and this as the south, what happens is that the magnetic field around the Earth is highly concentrated along the poles. It's like this, okay? So when there is a gap between these two magnetic fields, then what happens here, the effect of the magnetic field is less, but here it is actually concentrated more. So what happens is that these charged particles, when they actually move towards the Earth, they are attracted towards these regions, that is Earth's magnetic fields, towards the poles, okay? Then what happens when they actually come, in contact with the particles of the Earth's atmosphere, which is characterized by oxygen molecules, nitrogen, etc. What happens? It is excited and there is actually discharge of colors, okay? So that is what, like oxygen actually creates green as well as red and so on. Nitrogen creates another set of colors, and that is why you actually have these lights which are called as the auroras. So aurora, what to say, Aurora australis is actually towards the north pole, so that is what we call it as the northern lights, and Aurora borealis is towards Antarctica, Australia, etc. Do you understand? So this is what is the concept behind this. So you know what is Aurora australis, that actually takes place in the north pole, and the borealis actually takes place in the south pole, and how these are triggered is what I told you. The charged particles are there, they are actually moving or attracted towards the Earth magnetic field. I told you there is excitation that actually takes place, and then what happens is that the different atoms or the molecules that are actually present of oxygen and nitrogen, when they collide, that actually releases in the emission of light. For example, nitrogen actually gives out blue or a violetish color, and also this can be characterized by geomagnetic storms. I don't want to confuse you with that particular concept, so let's actually leave that. This is the concept of Aurora borealis and australis, okay? So here, this is also important geophysical phenomena, whatever activity actually takes place on, because of the Earth or the interactions in the solar system. So this is what it is. So you have to answer this in 250 words with diagram. So if you see here, you have the solar flares which is ejected from the corona, that is the outermost layer, and the solar wind actually moves over here, whereas you see it is concentrated or attracted towards the poles of the Earth, and that is where the excitation actually takes place, and then there is actually the visible colors to our eyes in the form of aurora. Now moving forward, the last question over here is, what is a twister and why are the majority of twisters observed in areas around the Gulf of Mexico? So very interesting. First, twisters are nothing but they are tornadoes, okay? So I would like to explain you the concept very simply, okay? So you know what is a convection cell, right? So what is a convection cell? What happens is, this is an area of low pressure. So area of low pressure, air actually rises, this is warm air. It goes to the area of high pressure, again it actually sinks. So this is called as the convection cell. So when this convection cell actually happens on a large scale, which is characterized by higher temperature and more of warm temperatures as well as low pressure, what happens, it results in the formation of thunderstorms. So first step, this is actually a convection cell. This second step, over larger area, that results in thunderstorms. So thunderstorms here can be of three types, okay? So they can be a single cell thunderstorm, they can be a multi-cell thunderstorm, or a supercell thunderstorm, okay? So this can be of three types, that is single cell thunderstorm, multi-cell thunderstorm, and supercell thunderstorm. So what do you mean by this? If the thunderstorm is characterized by this particular single, cell, convection cell, it is called a single cell. Similarly, when there are multiple convection cells like this, and when they combine together in order to result in the thunderstorm, that is called as the multi-cell thunderstorm. And next is the supercell thunderstorm. Okay. So what do you mean by a supercell thunderstorm? The supercell thunderstorm is actually characterized by high wind shear. So what do you mean by high wind shear? So one thing you need to understand is the supercell thunderstorm is what causes your tornado. Okay, so the supercell thunderstorm is what actually causes your tornado, and this tornado is characterized by high wind shear. So what do you mean by high wind shear? The difference in the nature of the air. That is, one portion, that is the lower surface, is actually very warm. The upper portion of the air is actually very cold. It is moving in the opposite direction. Then what happens? If this is actually warm air, low pressure, warm air, if it is moving in this direction, and then it is characterized by high pressure, cold air, what happens if it's moving in this direction? The air in between, right? This actually swirls like this. Understood? And what happens is, one of the characteristics of this supercell thunderstorm is that it has a very high or strong upper draft. Okay, upper draft is the air actually rises to very high heights, okay, or very high altitude. So when that actually happens, it lifts this entire system up, and then it actually results in this kind of a tornado. So this is actually the simple mechanism of twisters or tornado. So what is a twister? Twister is nothing but when the convection cells, that is when warm air actually rises up, and then what happens, it actually subsides, or it reaches the high pressure and subsides down because of the high pressure, and that is actually characterized over a long or a large area involving higher and higher temperature, which is actually very strong. That results in thunderstorms, and thunderstorms are of different types, and when that is characterized by the supercell thunderstorm, which actually has a higher upper draft, it lifts the entire system, and when that actually makes a landfall, that is called as the tornado. Okay, so this is a twister. Tornado is basically a twister. So this is explained here. And why are majority of the twisters actually observed in areas around Gulf of Mexico? Yes, this is also another good question. Why is it actually in seen around Gulf of Mexico? So this is the process I actually told you. This is the stronger west winds aloft, and this is the southeast winds near the ground, and here the entire system is actually lifted up, and now when it actually makes a landfall, this causes damage to property and life along with some rainfall, and this is called as the tornado or the twister. Okay, so this is what it is. So here you have the funnel shaped, or it's called as the funnel cloud. Okay, and this is a supercell thunderstorm, happens over a large area, and it has a very strong updraft, that is reaching up to greater heights. So this is what it is. Yeah. So why is this actually found or prominent in this particular region? Let us actually see. One of the reason is it is actually very or it's present in proximity to the warm ocean waters. So you can actually see it has proximity to warm ocean waters because this is the Gulf of Mexico region. Okay, so there is warm ocean water. Also, you have the warmer North Atlantic drift over here. Okay, so that is one of the reasons why it is actually here, and there is also clash of air masses, that is the the hot as well as the cold air mass. Here you can see the cold dry air which is actually coming from the Rockies as well here, and then you have the warm air going over here. So when that actually meets, it actually causes this tornado to fall in this particular region where it is, where you have Oklahoma, Kansas, Nebraska, Texas area, etc. So that is one of the reason. Next is positioning of the jet streams. Jet streams are nothing but these are upper tropospheric winds. Okay, so they also actually have the dip southwards over here. When they actually are over here, upper circulation, it dips towards the south, and that is also one of the causes for the occurrence of the jet stream, occurrence of tornadoes over here. And next reason is the flat terrain. The flat terrain of the Mexico region actually causes the, what to say, uninterrupted occurrence of tornado. Okay, so this is what it is. So here we've actually explained about the 5 different questions that have actually come in your geography paper. So these concepts of tornadoes as well as temperate cyclones, tropical cyclones, how they are actually different from each other and why they are particularly focused in this particular area. Over here they've asked about twisters, why in the Gulf of Mexico region. All these are analytical questions which will actually, you will eventually be able to decode as you practice and you get a conceptual clarity. So I hope you actually enjoyed this particular session. So for further doubts or for more such live updates and doubt clarification, please do reach out to us and please do like, share and subscribe to Narayana IAS Academy YouTube channel. Thank you. I was not at all interested